So we saw something there at the end of the last video that we want to tease out a little bit more, namely that speed and velocity are not the same thing. Speed and velocity are related, but they're not the same. And similarly, displacement and distance are not the same thing, but they're related to each other. And we kind of want to dive into that a little bit more. So imagine a particle moving along a line, for say in a north-south direction, right? Just for example. Now remember, we're moving along a line because that's the only thing we know how to do is one-dimensional motion. We don't know how to do anything else at this point. So we're just pretending that this line is just going north and south. So one-dimensional motion. With a velocity of v of t in meters per second over the interval 0 to 4 in seconds. And I have it drawn here. So these are graphs of v of t. V of t, right here. V of t. And in v of t, you can tell because it's linear, so I can actually find what v of t is. V of t was equal to 20 minus 5t, which is not given, but you can tell what it is just by using algebra. All right, so what is the particle's displacement and what is the particle's distance? They're not the same thing. So displacement, distance. Okay, now we should have learned this hopefully in Calc 1, but this should be just a review, but if not, let's go over it. Displacement is the change in position. Oh, and the delta sign means change. Delta, just to make a little note somewhere for you here real quick. Delta means difference. Get it? D, that's the Greek letter for D. D for difference, D, right? So difference, which means change, right? So in science class, they tend to write deltas a lot, and they'll write it in physics for you a lot. It means change. So I'll use it a lot too, okay? So it's the change in position right here. So displacement is the change in position, and then that would mean it's basically S of B minus S of A. Okay, well, I wasn't given S. This isn't a graph of S. This is a graph of velocity. So to find that, I would have to find the integral. Hopefully you were saying integral in your head. Okay, so to do this, let me just write this right here. Change in position, okay? But I don't have position. Position wasn't given to me. So to do this problem, I would have to find the integral of velocity from A to B. So if I want it from 0 to, oh, they said 0 to 4. I don't like it. I think that's a typo. I'm sorry. That's 0 to 6. Sorry. 0 to 4 isn't interesting. We're going to go 0 to 6. Sorry. Typo. Okay. All right, so I want to find S of 6 minus S of 0. So I've got A is 0, B is 6. So if I want to find that displacement, if I want to find it, I need to find the integral of velocity from A to B, which in my case would be the integral of 20 minus 5t from 0 to 6, which would be 20t minus 5 halves t squared from 0 to 6, which is 30, in case you want to see it. Now you actually could figure that out from the problem without even having to do the integral, in case you're interested. Because if you look at the integral here, this region right here is positive, and you can tell what it is worth because it's a triangle. Triangles are not exactly difficult to find. It's got an area of 40, right? 1/2 base times height. Base is 4, height is 20. A half of 80 is 40. And then this part right here, and again, 1/2 base times height would be 10. Right? So you could also get it not by just taking the integral, but you could also get it from 40 take away 10, right? So it's 40 take away, because this is below the x-axis. 10 and 40 take away 10 is 30. Okay, that's displacement, right? So displacement makes this number here a negative. So sorry, I don't like that. That's so faint and hard to read. So this is 40, this is 10. 40 take away 10 makes 30. So yes, I could do this particular one by doing the integral, but I could have done this problem even without an integral by taking 40 take away 10. All right, so that's displacement. What about distance? Distance is the total distance covered. Oops. Which is not the integral of velocity. Ooh, I should have put that in that box right here. Sorry. It's not the integral of velocity. It's the integral from A to B of speed. There, I rewrote it just so we could see it a little bit better. So speed, which is the absolute value of velocity, that is distance. So if we think about what we would do for this particular problem, we still have the 40 right here. From before, right? So that's still 40. And the bottom part is still 10, but the trick is that you don't make it down there. You make a companion up here that's always positive, because the absolute value of velocity cannot go negative. And then we make this piece right here positive 10 rather than negative 10, right? So this one you can think of as negative, this one you can think of as positive. So I can tell what the total distance is going to be. It's going to be 50. So in this particular problem. Now, how would I do it if I had to do it by hand? Well, if I wanted to do this by hand, I would have to separate my integral, right? You might not remember, but that's what you have to do from Calc 1. So you'd have to take the integral from 0 to 4 of 20 minus 5t dt, and then another integral from 4 to 6, but of the opposite, negative 20 plus 5t from 4 to 6. You're taking the negative of each of the terms. Or if you like, you could put a negative out in front, either way. One way or another, though, you're going to get 40 plus 10. Right? It will not be minus 10 like this other one was. I don't know why I made that green. That was kind of dumb. There we go. So it was 40 take away 10 for displacement, but it's 40 plus 10 for velocity. Now for simple graphs like this, it's really nice because it's easy to see. 40 take away 10, 40 plus 10. It's much harder if you cannot find it easily and you have to break up the integral yourself and do it piece by piece. All right, so given a position of an object along a line at time t, denoted S of t, is the location of the object relative to the origin. A position function S of t with its accompanying velocity function. I don't know what that means. Oh, I must have meant that to come over there. That's okay. Velocity is speed with direction. It's the slope of the tangent line to position. And speed is the absolute value of velocity. Speed can only be positive. Velocity can be positive or negative, depending on what direction you're going. And I don't think I really meant to have, oh, I think I meant to have this part up here. Sorry about that. That's a little typo. Just with its accompanying velocity function. I don't need this piece again. There we go. Sorry about that. Okay, so that's how speed and velocity relate. And then displacement and distance relate similarly, but not quite the same, right? So displacement is distance with direction. All right. right? So displacement could be positive or negative, right? So distance with direction means could be positive, could be negative. It depends on where you end up and where you started, okay? So it's your net change in position. So it's equal to the integral from a to b of v of t dt, which means you're finding the area between the velocity function and the t-axis, or the x-axis. Right. So if we look down below at this example, our displacement would be area 1 minus area 2. That second area is negative, right? Okay, so that's lovely, wonderful, beautiful. And just another note real quickly. This is a definite integral because you're picking particular points. If you don't do a definite integral, if it's just the general integral of velocity, that's your position function. Right? Okay, so then what about distance? Right, so we did displacement. Displacement's pretty easy, right? It's just the net change in position, so it's the definite integral, no problem. The total distance traveled, which is distance, is always positive. Always. Right? Cannot be negative. And it's the area between the speed function and the t-axis. So it's the total change in position. Not the net change, but the total change in position. Net implies that this will be negative down here. Total implies that they'll both be turned positive. So the total distance traveled will be A1 plus A2, right? These are the same areas, but this one has it negative. This one's flipped it over and made it positive, right? And it would be the integral from A to B of the absolute value of the velocity function, which, to be real with you, if I call this part right here C, just for the fun of it, then what you have to do is you have to take the integral from A to B, or excuse me, A to C, A to C of your velocity function, plus from C to B of the negative velocity function. All right, that's how you would have to do that. So it's much more difficult because you have to find, of course, this value C, you have to turn this integrand negative, you have to do all this correctly, etc. Okay, so real important stuff, right? The displacement and the distance are not the same thing. Displacement's much easier to find, distance is much trickier. And moreover, speed and velocity are not the same thing. Velocity is speed with direction. In other words, speed is the absolute value of velocity. And that difference matters for the integrals here, for distance or displacement here on the left and distance here on the right.